Welcome to this lesson on the matrix and the decision of entry. This lesson is broken into two parts to discuss two interrelated structuring techniques, the matrix and the decision of entry. During this course, I use the term decision tree, decision event tree, event decision tree, and scenario tree interchangeably. One of the tools I find the most useful in helping me organize the various elements of a problem is the matrix. Unlike the matrix that Neo found himself in, the matrix we'll use is nothing more than a grid with as many cells as needed for whatever problem is being analyzed. A matrix is one of the handiest, clearest methods of sorting information. Anytime I can reduce information to a matrix, I find it analytically illuminating. For example, an interrogator is preparing to question a suspect in a terrorist bombing of a U.S. military facility. He wonders if the suspect will be truthful, and begins to develop two different interrogation strategies depending on whether he believes the suspect is being truthful. He asks you to help him prepare his interrogation strategy before he begins. How many possible scenarios should the interrogator prepare for? Create a matrix to structure this problem. Please pause the video if you need more time to build your matrix. My matrix shows there are actually 4 general scenarios that the interrogator should prepare for. Knowing this, he can now prepare a specific interrogation strategy to fit each possible scenario. Let's try another exercise. In this scenario, you're a warning analyst on the watch floor. Which one of the circumstances listed on the slide would be best from the standpoint of your professional reputation? Pause the video while you construct a matrix to represent this problem. You should have constructed a matrix similar to this one. Note how nicely the matrix organizes, structures our analysis of the problem. There are 4 possible outcomes, 4 cells, where the predictions and the outcomes intersect. The matrix facilitates our thinking by stripping away the superfluous language that surrounded the key ideas contained in the previous 4 sentences. The matrix also juxtaposes these ideas in a way that enables us to isolate their connections in the cells and to perceive more easily and clearly the distinctions among them. We'll look at this problem again later. Let's look at another example of how a matrix can facilitate analysis. On a sheet of paper, create a matrix from the information listed on the slide. This is good practice in constructing a matrix. Don't be upset if you have difficulty doing it. The more you use matrices, the easier it will become. Pause the video while you work on your matrix and restart the video when you're complete. Your matrix should look similar to the one shown on the slide. Creating a matrix is a piece of cake once you get the hang of it. Note how putting the numerical data into the matrix has the effect of isolating the data so they can be easily analyzed, both separately and in combination. Do you find it easier to focus on the data when they are in a matrix than when they are presented in sentences? When analyzing the data in the matrix, be sure to ask yourself questions about whether there is a correlation between eating at the dining facility and contracting anthrax. Based on the data in the matrix, what's your answer to the question on the slide? Write your question down before continuing. 85% of nurses who were given a similar problem thought there was a correlation, pointing out that there were more cases of those who ate at the dining facility and those with anthrax, 37, than in any other of the 3 categories. Before we continue our analysis of this problem, convert the numbers in the matrix into percentages, so we can see what percentage of those who ate at the dining facility contracted anthrax and didn't. We'll then compare our percentages in that row with the percentage of those who didn't eat at the dining facility but contracted anthrax or didn't. Pause the video while you convert your data into percentages. Your matrix should look like this. Did you make sure your percentages across the rows add up to 100%? Again, I ask, what's your analysis of the percentages in the matrix? Is there a correlation? You should have concluded that the nurses were wrong. There is no correlation between those who ate at the dining facility and those who contracted anthrax. I think that answer becomes clearer when viewed as percentages from the standpoint of who ate at the dining facility. The percentage of those who ate at the dining facility and have anthrax is roughly the same as those who didn't eat at the dining facility yet have anthrax. Actually, the percentage of those with anthrax among those who didn't eat at the dining facility was slightly higher than those who ate at the dining facility. If the proportion is roughly the same in both cases, then obviously there is no correlation. Putting the numbers in a matrix allows us to structure the analysis of data easily and meaningfully. I hope that why you should use a matrix is obvious. Review the bullets on the slide to reinforce the points that you experienced during the exercises. Learn to use a matrix. It is a marvelous analytic tool. We'll continue the lesson on decision event trees in the next lecture.